Welcome back, students. The purpose of this video is to help you through your homework 29, which is your systems practice test. So if it's not appearing on your home screen, please go to your assignment list. Remember that this is where you can see all of your current homework assignments, as well as over here what your current score is. So this one that we are going to do is called homework 29, the systems practice test. Yours will not be password protected, but right now I don't want anyone else to access it. So I have it password protected, and on the day it is assigned, that will not be there. As you can see that there are 9 questions, you are going to have a test that is very similar to this assignment that will also have these same 9 questions on it. Really, the only difference between this homework practice, your practice test, and the actual test itself is that as you are going through the homework, if you want to, over here on a homework assignment, you can always click explanation, you can click view an example, and after you complete the problem, you can check your work to see if you were right or wrong. You also get 3 attempts as you're going through the homework assignment, and then if you miss those, you can still do another attempt. The way that the test will work is you'll have to go through all 9 questions, submit your test, and then you get to see what you got right and what you got wrong. You will have 2 overall attempts on that test, and it will be a quick retake, which means that you will only take the problems, you will only redo the problems that you missed on your first attempt. Now, before you redo an attempt, so before you take your second attempt, make sure you go to your report and see a detailed analysis of the questions that you missed. Make sure that you ask your teacher any questions that you might have, prepare, study, make sure that you know how to do those problems, and then redo that test for that second attempt. All right, so best way to practice for that test is to do practice problems. So on the very first question, a system of equations, remember that a system means that you're going to have 2 lines. And those 2 lines, there are 3 possibilities for what graphically those 2 lines are going to look like. Either the 2 lines are going to intersect at a single point, like this last system for me, or the 2 lines are never going to intersect because they're parallel, or the 2 lines are actually 1 line because when you graph them, they overlap. They turn out to be the exact same line. Let's start off with system A. So when I look at my equations, I can't tell just looking at the equations that they're the same. If I solve for y, then I'd see that the equations are the same. But looking at the graph that is already provided for me, I can see that they had to have been the same because it's 1 line. It says line 1 and line 2. To be a solution to a system, you are looking for the point or points that the lines have in common. So in this case, any point on the line is a solution, which means that there are infinitely many points on a line, so there are infinitely many solutions to this system. For the second example, the 2 lines are parallel. To be a solution, it has to be a point that is on both lines at the same time. These 2 lines never intersect, which means they never have a point in common, which means that there is no solution. For the last system, the 2 lines that we have intersect at 1 single point. So what you would need to do is figure out what is that 1 point that they have in common, and then that is the ordered pair, that is the 1 solution that would make a true statement for both equations. So type in the x-coordinate followed by the y-coordinate. So when I put my cursor right here, I see that my x, I didn't leave the that y-axis. I didn't go left or right any, so that's 0. And then I went up 1. So this would be the ordered pair 0, 1. So for this homework assignment, I can click check, and it will tell me if I got it right or wrong. If you missed it, you should be able to try again or try another problem and keep going until you get it right. For the second problem, it's very similar to the first one, except the graph is not already provided for you. So you're going to need to use the equations that are given to you and graph those lines, and then interpret the graph. So for this, we have our 2 equations that are given to us already in y equals mx plus b form. So remember, this slope-intercept form, the number in front of x tells us our slope. So for the first line, this slope would be -3 over 1. And the number after x tells you the y-intercept. So in this case, it's going to be a +4. So what that means is, on the y-axis, I would plot a point at +4. And then the slope tells me how to move. So negative means I'll go down 1, 2, 3, and then always move to the right. So if it's negative, you'll go down, and if it's positive, you'll go up, and then that bottom number tells you how far you'll go to the right. So there is the first line. Second line, we'll do the same thing. We are going to identify the slope and the y-intercept. So for this second line, the number in front of x, I don't see one. All I see is a negative sign. So that's an invisible -1. So I'm going to write that as a fraction, -1 over 1, and the y-intercept is +2. So I'm going to get my line tool, and on the y-axis, I plot a point at +2, and then the slope tells me I'm going to go down, since it's negative, and then over 1. All you need to do is plot 2 points, and then ALEKS will make the rest of your graph for you. Now, you are not finished with the problem. You did pretty much all of the hard work, but now you have to interpret the solution. So remember, the solution to a system is any point that they have in common. In this case, the 2 lines intersect at a single point. What is that ordered pair? All right, so had the lines been parallel, it would have been no solution. Had they been the same line, it would have been infinitely many solutions. These 2 lines intersect at a single point, so I'm going to click on the ordered pair option, and then I'm going to type in what is that ordered pair. So that is going to be at 1, 1. Remember that at any time as you are taking your practice, as you're doing your homework, you can click check, and then it will tell you if you got it right or wrong. So in this case, we got it right, so I'd move on. If you miss it, please keep trying until you get it all the way right and you understand what you are missing. The point of homework is to practice, practice, practice. My next question, almost the same thing. I'm given my 2 equations, but this time, both equations are not solved for y. One of them is, the other one is not. So for my first line, I can go ahead and proceed like I did on the last one. It's already solved for y, so I can look in front of x and know that my slope is +1 over 2. And this time, the number after x is a -3. All right, so what I would do is I would take my line tool, and my y-intercept is -3, so I go down to -3 and I plot a point on the y-axis. And then my slope tells me how to move, so it's positive, so I'm going to go up 1 and to the right 2. And then I'll plot my second point, and then it automatically plots my line for me. The second equation is going to take some work. So this is really the first item that you would need to show on a work page. All right, so on a work page, it'd be a good idea to get your name, to get the homework number, and then label that this is for question number 3. And here is our equation. We have -2x plus y is equal to 0. Our goal is to get this in the form y equals mx plus b. So notice that when I have this in the form y equals mx plus b, nothing else should be on the same side as y. So that means this -2x needs to go to the opposite side. So to move opposite, I have to do the opposite sign. So if this is a -2x, I have to use a +2x. I'm going to add 2x on both sides. The -2x plus 2x cancels. I'm left with positive y equals. Now this is a number without a variable, and this is a number with a variable. Notice I'm going to put the number with the x first, followed by that number without. So this is going to be positive 2x, and then a positive 0. So then I identify my m, which is my number directly in front of x, which is a +2 over 1. And then my b, my y-intercept, what comes after x, which is a +0. So now that I have put this into slope-intercept form, I can graph using my y-intercept and my slope. So the y-intercept on the y-axis, it's at 0, so I plot a point at 0, and then my slope is positive, so I'm going to go up. And my first number is 2, so my top number is 2, so I go up 2, and then I move to the right 1. My second line is automatically graphed the rest of the way for me, and then I need to figure out what is that solution. So my solution is down here where the 2 lines intersect at this single point. They weren't parallel lines, so that means that they're not no solution. It wasn't the same line, so it's not infinitely many solutions. They intersect at a single point, so it's an ordered pair. For this example, the ordered pair would be at -2 and then down 1, 2, 3, 4. So the ordered pair I would type in would be -2, -4. And then once again, for homework, you can click check. For a test, you're just going to have to move on to the next question. If you missed it, again, please keep going until you get it right. All right, so that is graphing. Other ways to solve a system is by substitution or elimination. This says use substitution to solve the system. If you want to solve using elimination, you may, but the reason why this one tells you to solve using substitution is because it is already set up for substitution. So you will definitely need to have work for this problem. So on your work page, label this as question number 4, and then write your two equations that are in your system. For substitution, it's easiest if you write them side by side. So if we have x equals 3y minus 7, and we have 5x plus 4y is equal to 3. Remember that substitution, another word for that is replace. So what that means is we have a variable that is already all by itself in an equation. So the x is already all by itself. It's the same thing as 3y minus 7. So these mean the same thing. So what we can do is in our other equation is replace or substitute in for x what it tells us over here that x is equal to. So now I'd go through and I'd rewrite this equation. So I'd have 5. But now I'm going to replace x with 3y minus 7. It's very important that you use parentheses around your substituted value because we're going to have to go through and use order of operations in order to solve the equation. So notice that everything else in this equation is what we had up above. 5x plus 4y equals 3. Only difference is I replaced x with what it told me x is equal to over here. So now this takes us back to chapter 2 where we solved equations. So solving an equation, you need to separate the left-hand side from the right-hand side. And on the left-hand side and right-hand side, simplify it as much as possible. So over here, I need to get rid of parentheses, which means multiply. So I'm going to take 5 times 3y, which will give me positive 15y. And then I'm going to take 5 times negative 7. Please use a calculator if you need to use a calculator. So a Desmos scientific calculator will be allowed on your test. So what you could do is you could type in 5 and then times negative 7. And that answer will pop up over on the other side. So this gives me negative 35. And then I do not do anything with the plus 4y. It wasn't in parentheses, which means it doesn't get the multiplication. All right, now the variables. Notice that I have a 15y and a 4y. They are on the same side. So if they're on the same side, just combine. So I'm going to take positive 15 plus 4, which again, if you need to use the calculator, use the calculator. But that's going to give me 19y minus 35 is still over there, and then equals 3. So now to undo, to try to figure out y times what minus 35 is 3, I go through and I work this backwards. So y is attached to 19. It's hard to get rid of things that you're attached to. So get rid of what it's unattached to first. So this minus 35, the opposite of a minus 35 would be plus 35 to both sides. So I'm going to add 35 to both sides. These cancel each other out, leaving me with 19y is equal to positive 38. Then y is attached to 19. It's being multiplied. To undo multiplication, we divide, and we're going to come up with y is equal to 2. All right, now that is one number. Notice over here we have 2 variables. So we're not finished yet. We only have one of them. So you're going to have to plug it in again. Okay, using substitution, you have to plug in twice because there are 2 equations, there are 2 variables. You can plug it into either equation, but the equation that had already been solved for x is the easier one to plug this into. So I'm going to rewrite the equation, but instead of writing y, we know that y is the same thing as 2. So what I'm going to do is I'm going to replace y with a 2. And then I still have a minus 7. So this is going to give me x is equal to 3 times 2 is 6, and then minus the 7, again, please use a calculator to help you with that basic arithmetic, but it gives me that x is equal to negative 1. So I could type my answers as an ordered pair on my graph problems, but on these problems it has that separated for me. And so I'm just going to type in x equals negative 1, y equals 2, and then please check. Please make sure that you're going through and doing them right. And if it's wrong, go back and try to find your mistakes. All right. Next question is going to be very similar, except this time it is set up for elimination. If you want to use substitution, you can use substitution. But this question is set up for elimination, so I'm going to work through it using elimination. So on my work page, I would label my next question as number 5, and then I would write down my system. This is 4x plus 3y is equal to 4. And then I also have 4x plus 6y is equal to 16. The reason why this is set up for elimination and not substitution is because it's vertically lined up. For substitution, you have to have one equation with a variable all by itself. My variables are attached with numbers and they're on the same side. So this is set up perfectly for elimination because I have my x's followed by the y's, then the equal signs are on top of each other, and then the numbers without the variables. All right, so if I go through and I try to add these two together, 4x plus 4x would give me 8x, 3y plus 6y would give me 9y. The process is called elimination for a reason. We're trying to eliminate either x or y. If we just add these together, they don't cancel out. So if that's the case, then you're going to need to go back through and in one equation only change all of the signs. So what I'm going to do is on my first equation, I'm going to take my positive 4x and make it a negative 4x. In my second term, same equation, but I'm going to take it from a positive 3y to a minus 3y. And then same with my positive 4, I'm going to turn that into a negative 4. And now I'm going to try again. So what happens now when I add the two together? Well, negative 4x plus 4x cancels out. Negative 3y plus 6y gives me positive 3y. Again, if I need a calculator, I would type in negative 3 plus 6, and that's going to give me the positive 3, and then keep the y attached. Equals negative 4 plus 16 gives me positive 12. Y is being multiplied by 3, so we're going to divide both sides by 3, and we get that y is equal to 4. All right, that's one of our variables. To get the other one, you have to plug it back in. So pick one of the original equations. I'm going to go with the original first, which is 4x plus 3. But now that I know that y is 4, what I would do is in the original equation, replace y with 4. So instead of writing y, I'm going to replace it with 4, and then equals 4. The reason why it equals 4 is because I continued writing this equation. So this says equals 4. So I still have 4x, but this means multiply. So 3 times 4 is positive 12 equals 4. Separate the left from the right. X is attached to 4. We get rid of what it's unattached to first. So the opposite of a plus 12 would be minus 12 on both sides. These cancel out, leaving me with 4x is equal to, and then 4 minus 12 would give me negative 8. Divide both sides by 4, and I come up with x is equal to negative 2. So then I would type those two values in. Again, for the graphs, they had you type them in as an ordered pair, if you could. But for these, we just separate them. We have x is equal to negative 2. We have y is equal to positive 4. We'll check our work to make sure that we're right. And if we mess something up, we'd go back, we'd find our mistake, and we'd learn from it. Our next question is going to be very similar again. But this time, it's not quite as easy as the last one. We are still going to use elimination because it's still set up for elimination, but we're going to need to do a little bit of work. All right, so question number 6 on your work page. Please write down question number 6 and write down the system of equations. So you have negative 7x minus 5y is equal to negative 7, and then negative 5x minus 4y is equal to negative 2. You have some choices on this. Okay, if you add these together, negative 7 and negative 5 makes negative 12. Negative 4 and negative 5 makes negative 9. Nothing eliminates. If you go through and try to change all of the signs on one of the equations, so we'll change this to a positive, we'll change this to a positive, we'll change this one to a positive. If we add these together now, we come up with negative 2x and then minus 1y equals, so same thing, nothing eliminated. So this is where we have to use a little multiplication. We're going to have to manipulate the problem to force a variable to cancel. You get to choose which variable do you want to cancel. All right, so I'm going to go back to my original problem. Okay, so my original equations, which was negative 5x minus 4y equals negative 2. And then I'm going to choose. It does not matter. Sometimes there's a little bit easier one than the other, but it really doesn't matter. Do you want to eliminate x or do you want to eliminate the y term? Most of you like to eliminate x just because it's the first one. So I'm going to go ahead and I'm going to eliminate x. So right now, I have a negative 7x and I have a negative 5x. I need these to be the same number in front with opposite signs. So first thing I notice is that they have the same signs. So that means that one of these, and it doesn't matter which one of these is going to have to get multiplied by a negative. All right, now I need to make it so these are the same number. So 7 and 5, what is the smallest number that they both go into? And if you can't think of the smallest, just multiply them together. All right, so 7 and 5 both go into 35. So how I'm going to transform this into a negative 35x is just to multiply by positive 5. This one, I need to be a positive 35x because it's a negative 35 plus 35 that cancels, that eliminates. So negative 5 times negative 7 is what gives me positive 35. All right, so my first equation, this negative 7, needed to multiply by 5. So that means I need to take my entire first equation and multiply the entire first equation by positive 5. And my second equation, I need to multiply everything by negative 7. All right, so let's go through and do that. And please use a calculator to help you with the arithmetic. So 5 times negative 7 is going to give me negative 35x. 5 times negative 5 is going to give me negative 25y. Equals 5 times negative 7 is negative 35. My second equation is all getting multiplied by negative 7. So negative 7 times negative 5 is positive 35, and it has the x with it. Negative 7 times negative 4 is positive 28. That has the y with it. Equals negative 7 times negative 2 is positive 14. All right, so now I am ready to go ahead and add these two equations together. And notice that my x's, negative 35 plus 35, sum to 0. They cancel each other out. So because they cancel each other out, that is good news because my process is called elimination. All right, next thing that I have, my next term, is negative 25 plus 28. So 28 minus 25, again, use a calculator if you're not comfortable with that, but that's going to give me 3y. Equals negative 35 plus 14 is negative 21. So now I solve this equation. Y is being multiplied by 3, so I'm going to divide both sides by 3, and that's going to give me that y is equal to negative 7. That's one of my variables. I still need to find the other one. So go back to one of the original equations. So the first equation or the second equation, I'm going to go with the second one, negative 5x minus 4. But instead of writing y, I'm going to replace it with what I just got y to be equal to, which is negative 7, equals negative 2. So this will give me negative 5x, and then negative 4 times negative 7 is positive 28, equals negative 2. So get rid of what x is unattached to first. That's this plus 28. So I'm going to minus 28 on both sides. These cancel out, leaving me with negative 5x is equal to negative 2 minus 28 is negative 30. Divide both sides by negative 5, and you come up with that x is equal to positive 6. All right, so I type in that x is positive 6, and my y is equal to negative 7. I'll check my work on my homework, make sure that I'm right, and again, if I'm wrong, go back, find your mistakes, and fix it. All right, the next question, you can probably guess what it's going to be. Very similar. This time, however, I'm given 2. All right, so even though it says 9 problems up here, this is really going to be a 10-question assignment, 10-question quiz, because this one has 2 questions in one. All right, so on my work page, I should write down 7A. All right, so this is going to be my work for 7A. I have the system 3x plus 5y is equal to 6, and then I have 3x plus 5y is equal to 5. This is set up for elimination because I have x's followed by y's followed by equals followed by the numbers without the variables, the constants. So if I try to add my two equations together right now, I'm going to come up with 6x plus 10y. Nothing canceled. So what I'm going to try to do next is just change the signs on one of the equations. So if I change all the signs on my second equation, that means I'm going to go from a positive 3x to a negative 3x, from a positive 5y to a negative 5y, and then from a positive 5 to a negative 5 over here. So now I'm going to try this again. I'm going to try to add them together. And 3x minus 3x cancels out. So that's good news. I didn't have to multiply by anything other than changing all of their signs, which was multiplying by negative 1. So these eliminate. So now I continue with the problem. 5y minus 5y. Whoa, those also eliminate. So that means that everything eliminated on the left-hand side of this equal sign, which means this is going to be 0. Over here, I have 6 minus 5, which doesn't cancel, but it reduces down to 1. So remember, if you have all of your variables that cancel, you're either going to have this case of no solution or the infinitely many solutions. Go back and look to see if your statement is true or false. In this case, it is false, okay, which means that we're going to have the case of no solution. Had it been true, it would have been infinitely many solutions. So think about what this means. This means if there's no solution, these two lines never intersect, they're parallel. Well, yeah, that makes sense. These two equations are basically the exact same. Everything's the same over here, but their numbers over here are different. So that means that they'd move the same way, but they start at a different place. So they will never intersect. Again, I know that because both of my variables eliminated, and I was left with a false statement, so that was a no solution. My second system on this one, so on my work page, I would label it as 7b. My second one, I have y equals 6x, and I have y is equal to 4x. All right, I can either use substitution or I can use elimination. The choice is yours for how you want to solve it. On this one, I think what I'm going to do is go ahead and continue working with that elimination. Now, it's a little bit different, but it's still lined up for elimination because I have y's on top of y's, then my equals, and then my x's. All right, so it's still vertically lined up. So if I try to add my two equations together right now, I have 1y plus 1y, which would give me 2y, and then 6x plus 4x, which would give me 10x. I wanted to use elimination. Nothing eliminated, so I have to go through and try again. So first thing that I would do before trying to multiply by something is to change all of the signs in one of my equations. So let's change the first equation. Doesn't matter which one you do, but I'm going to change this y to a negative y. I'm going to change this 6x to a negative 6x. Now I'm going to go through and add these together. So negative y plus y would give me 0y, or that's just 0. They cancel each other out. Bring down the equal sign, and negative 6x plus 4x gives me negative 2x. Now this is different. Up here, both variables canceled. Here, I still have negative 2x, so nothing canceled besides the y. My x's is still there, which means that I'm going to keep going. I have to solve this equation. X is being multiplied by negative 2, so I'm going to divide both sides by negative 2. 0 divided by negative 2 is 0, so this gives me that x is 0. That is a point. It's at 0. Okay, which means that this is going to have a solution. It's going to have exactly one solution. Let's figure out what that y value is by plugging that value back in. So the original equation, one of them was y equals 4x, but now we know that x is 0. So this is going to give us y is equal to 4 times 0, which is going to give us that y is equal to 0. So in my case, this won't be the same for yours. You're going to have similar problems, but your numbers are going to change. But in my case, my ordered pair is at 0, 0. That's the origin. My two lines, if I wanted to graph it to make sure that I'm correct, my two lines would intersect at the ordered pair 0, 0. And again, I will always check my work to make sure that I'm correct on my homework. You don't have that feature on your test, but we are going to give you that second attempt. So please make sure that you will check your work after you take the entire test, and then before that second attempt, make sure that you have figured out any sort of mistakes that you may have made. All right, so the last two questions are also going to require a little work, and they are both going to be word problems. So on question number 8, this is the easier word problem because it is just translating from English words to mathematical symbols, going from the English sentences to math sentences, what are called equations. So first thing you should do is come up with your two variables. So read through the problem. So the sum of two numbers is 39 and the difference is 5. What are the two numbers? So first thing I'm going to do is to find my two numbers, to find my variables. So I'm going to use x and y. So I'm going to let x represent the first number, and I'm going to let y represent the second number. All right, that question is going to help you to find your variables. Okay, now the rest of it's going to help us come up with the equations. It says the sum, which means plus. So if I sum my two numbers, x and y, I know that their sum equals 39. Difference means subtract. So if I take x and minus my second number, their difference is 5. All right, so some of you could figure those relationships, could figure out those numbers using some guess and check in your head. But if you need to, there is a way that you can solve it and get that answer every time, and that's using a system. This is set up perfectly for elimination because I have x's followed by the y's, followed by the equals, followed by the constants. And I can go ahead and try to add the two equations right now. So this is a positive 1x plus positive 1x, which would give me 2x. Positive 1y minus 1y cancel out, bring down the equals, and 39 plus 5 would give me 44. So 2 is being multiplied by x. I would divide both sides by 2, and this is going to give me that x is equal to 22. So I know that one of my numbers is 22. Now I'll go back to one of the original relationships. The sum of the numbers is 39. So that means if 22 is my first number, I can figure out my second number by undoing the addition by subtracting. So if I take 39 and subtract 22, that is going to give me what my second number is. Again, if you need to use a calculator, feel free to use a calculator, but I'm going to come up with my second number is 17. All right, so my two numbers are 22 and 17. It says larger number, so which number is larger, 22 or 17? That one's going to go there. So mine would be 22. And then my smaller number is going to be the 17. So that is the easier problem of the two word problems. The second word problem, we're going to go through and set it up the same way, only this time translating is going to be a little bit harder. So mine says a store is having a sale on trail mix and jelly beans. 6 pounds of trail mix and 5 pounds of jelly beans. The total cost is $35. For 2 pounds of trail mix and 3 pounds of jelly beans, the total cost is $15. Find the cost for each pound of trail mix and each pound of jelly beans. All right, so going through, reading the question, okay, right here, this question, the last sentence usually always holds for what you are going to try to find. Or for this problem, it also tells me what I'm trying to find here in the box because I'll be plugging in a number right here to answer the question. So what I don't know is the cost of each pound of trail mix. So I'm going to go ahead and call that one X. And I also don't know the cost for each pound of jelly beans, and I'm going to call that one Y. All right, so on my work page, so this is question number 9. I have my two variables that are defined. So my cost for the trail mix, my cost for the jelly beans. And now I'm going to go back through and I need to come up with two equations. So it says that they are having a sale. That's just background information. That's not really telling us anything we need for the equations. But this one says for 6 pounds of trail mix. So if you were to go to a store and buy 6 pounds, it will tell you the price per pound. We don't know what that price is, but we have a variable over there that's representing it. So that's 6x. So you would take 6 times whatever that cost is. That will give us the cost of how much you pay for the trail mix. But you're making a total cost, which means you're also paying for jelly beans, which means you also have to add that cost of jelly beans, and that is $5 for the cost times the cost of the jelly beans. So 5 pounds times the cost per pound, and that total cost is $35. The second equation, it says for 2 pounds of trail mix. So that's going to be 2 times whatever the cost is per pound of trail mix, plus 3 pounds of jelly beans. So 3 times Y. The total cost is, so equals 15. All right, so here is our system. Now we go through, just like we did for problems 4, 5, 6, and 7, we need to figure out, are we going to use substitution or are we going to use elimination? The choice is ultimately yours, but I'm going to use elimination because I have x's on top, and then I have my y values, and then I have my equals, and then I have my constants. So it's set up vertically for elimination. But if I try to add my two equations together, nothing's going to eliminate because I don't have the same numbers in front of a variable. I have a 6 and a 2, I have a 5 and a 3. Even if I change those to negatives, they're not the same number, which means that they won't make 0. So what I need to do is pick either x or y and eliminate x or y by multiplying it by a number that if I add them together, they're going to cancel. So in this case, I'm going to eliminate x. So if I want to eliminate x, I have a 6 and I have a 2. The smallest number that both of those can go into is 6, which means 2 to transform into a 6 needs to be multiplied by 3. Now, if I just multiply it by positive 3, I'll have positive 6, and 6 plus 6 is 12. I need it to be 0, so I need to multiply by a negative 3. So my first equation stays the same at 6x plus 5y equals 35. My second equation becomes negative 3 times 2x, which will give me negative 6x, negative 3 times positive 3, which will give me negative 9y, equals negative 3 times 15, which gives me negative 45. I will now add the two equations together, and 6x plus negative 6x makes 0, which means they eliminate. They cancel each other out. 5y minus 9y will give me negative 4y. And then 35 minus 45 is going to give me a negative 10. Y is being multiplied by negative 4, so I'm going to divide both sides by negative 4. A negative divided by a negative is going to give me a positive, which is good because we're dealing with money, and I don't think a store is going to say it costs negative dollars to buy. So positive 10 divided by 4 is 2.5. All right, money-wise, that means $2.50, which sounds like a very reasonable price for a pound of trail mix. That's only one of our variables. We also need to figure out, that was y. So that was the cost per pound of jelly beans. That was our y value. So we still need to figure out our x value, which is the cost per pound of trail mix. So we need to plug that into one of our original equations. So one of our original equations was 2x plus 3y is equal to 15. We now know that y is equal to 2.5. So in this equation where I see y, I'm going to replace it with 2.5. That gives me 2x plus 3, change my y to 3.5, I replace it, and then equals 15. So this is still 2x plus 3y equals 15, same equation, but y has been replaced with 2.5. So this is going to give me that x is equal to, I'm going to take 2.5 times 3, not equal to, 2x plus, so 2x plus, I'm taking 3 times 2.5, which is going to give me 7.5, and then this equals 15. X is attached to the 2, so get rid of the 7.5 first. So the opposite of a plus 7.5 is a minus 7.5. These cancel out, leaving me with 2x is equal to. If I take 15 minus 7.5, I get 7.5. And then I'm going to divide both sides by 2. And that's going to give me that x is equal to positive 3.75. All right, so here's why it's helpful to have defined your variables first. So now we know what variables are what. So in this case, our x was the pound per trail mix, which is 3.75, and our cost for the pound of jelly beans is 2.5. The dollar sign is already provided for us, so if we wanted to, we could put in 2.50, I'm sure. And then we check our work and make sure that it's right, and it is. Again, if something wasn't, then we would go back and we try to fix it, because the point of this assignment is to practice and practice and practice for your test, which will then be on the next lesson, the next day. So then submit your assignment. And just as a reminder, have I been submitting my test? Okay, then once I submit my test, it would tell me what I got. It would tell me I would have one of 2 attempts. And then before I would do another attempt on my test, I would want to click on the button that says Report. So the report is going to take you back through, and it's going to show you what each of your questions were. And up here, if I would have missed one of these, it would have then made one of them be red. And then I could click on whatever the question it is that was red, and I could go through, and it would tell me what the original problem was. It would tell me what the answer is that I submitted. And then if I missed it, it should also tell me what the correct answer was. Please make sure that you understand how to do all of this before you take that test, which will basically be identical. If for some reason you close out of that screen on your test before you look at your report, remember you can get to any report by going to, I don't think I have any old homework assignments, but you can go back to your assignment list, and if you click on your percentage, it will take you back to that report. All right, so please, please, please let us know if you have any questions. I hope this video helps because it goes through how to do every single problem, not only on this practice test, but also with what is going to be on your test over systems. Thank you for watching.